of the country. Just on our campus, several centers and departments have been started by our faculty. So we have played both in the institute as well as outside a big role, and we are happy to say that a lot of our alumni have occupied distinguished positions around the country. And this is our current strength in terms of faculty, students, postdocs, and staff, and everyone else. And per year, these are our numbers because numbers seem to be important for many people. But actually, our department values the intellectual contributions that our faculty and students and others make. And our students have actually gone on to many distinguished careers. And in fact, today's distinguished guest, Professor Anil Sahasrabudhe, is also our alumnus. And several of you are there, and Professor Ravi also. And it's actually very nice to see all of you here. And the research of the department is now put into 9 areas like this. And we have faculty who work on multiple of these areas. So there is a lot of multidisciplinarity in our research in the department. And these are our future, our assistant professors. In fact, Alok Kumar just got promoted, and 2 more people are going to join. And you can look at the areas they're working on, really top-notch areas. They all come from great universities. We have 2 more people joining, and we also have a research professor now in our department. That's just about our department. Now about this today's workshop. I welcome you all once again. And we have first welcome address by Professor Sahasrabudhe on behalf of AICTE. And then we have a recorded speech by convener of mechanical engineering section of INAE, Professor Arun Narasimhan. And then we have a session where we called it context setting. 5 of the committee, a committee appointed by AICTE to prepare a model UG curriculum for mechanical engineering. We will present our thoughts. And then 10 of the distinguished invitees are going to talk about their views on what we call distilled thoughts session. In these 2 sessions, there will not be any opportunity for question answer session. After that, we have breakout sessions for 1 hour, each in 6 topics. And there, everybody will get a chance to speak and express their opinions. And the people come back from the breakout sessions, and we'll have a summary session at the end. And please mute your mics when you're not speaking. And if you are turning on your video, make sure that your face is visible. And if your name is not exactly right, please try to change it if you can. So with that, I welcome once again. And now I request Professor Anil Sahasrabudhe to speak on behalf of AICTE and also as an alumnus of our department. Thank you very much.
So just one quick announcement. This meeting is being recorded just for everyone's information. Go ahead.
Thank you very much, Professor Anand Suresh, for organizing this event. Morning, namaskar to all of you. It all started with Professor B. Ravi, whom we had asked to revise the entire curricula as the chairman of the committee. We had Dr. P.V.M. Rao, Dr. Nag Hanumantaya, Dr. Chandrasekhar, and others who were all associated with this exercise. And during the transit, suddenly Professor Anand Suresh, who is also part of the committee, suggested that since IISc is celebrating its 25th year of mechanical engineering department, we must have a program which will talk about what should be the future of mechanical engineering education. And that's how this idea came, just not even 1 week back, and we swung into action, and we are here. And who's who of mechanical engineering of the whole country? You know, IISc has certainly contributed over 76 years. Several alumni who have occupied positions in different institutions, including directors of other institutions like IITs. And many of them are there today in the platform here on online mode. I see Professor Amit Ghosh here. My own guru, Professor Munjal, who is here. And, Gangadharanji, Sangeeta Kohli, Ashok Shettar, Rudra Pratap, Samir Khandekar, and many others who are either directly alumni of institute or they are associated with mechanical engineering field in the country. They are all here. At this juncture, I'm very delighted to be part of this celebration of 75 years of mechanical engineering department of IISc. The beginning itself, it was very, exclusively said by our Anand Suresh that mechanical engineering deals with solids, fluids, sound, and light. I think Professor Munjal, we are all together in both solid, fluid, and sound. Maybe light was not there so much in our thing, but we should throw light on many of the things which are happening in mechanical engineering today. And all the discussions which are going to flow today have all variety of necessities of today. Today we talk about the new education policy, which has given many wings. For example, multidisciplinary education, which is very highlighted, just that all research is already becoming multidisciplinary for a long time. And therefore, emphasis on multidisciplinary research universities called MERU. And then research and innovation having a lot of focus. But at the same time, going back into our Indian knowledge systems and how we connect with them. The very essence of education is for imparting not only information, knowledge, and wisdom, but also how we create human beings who are going to be having high integrity, honesty, and that is also important. And that's why Indian knowledge systems and values have also found place in this. So in general, education, as NEP 20 is talking about, is not only individual excellence, but how it will create institutional excellence, further leading to social excellence and national excellence, leading to a lot of innovations which will help the mankind. I think that is the holistic viewpoint which the new education policy has taken. And in the light of that, naturally, what should be the entry-level qualifications, what preparation students should have before they join, not only engineering, but for that matter, any domain of engineering, and in particular, mechanical engineering, which we are discussing. Further to that, what are the courses which should be there in the curriculum which will empower them, which will create employment on one side and probably entrepreneurship on the other side, how they will get emancipated, enlightened at the end of the education, and then become, not only empowered citizens, but they will, empower other citizens of the country. I think there are many challenges which the new education policy has been giving us as food for thought, and then we need to work on that. And that is where, in that context, AICTE has been doing regular curriculum revision, which is very important. Otherwise, teaching students 20th century subjects in the 21st century does not make any sense. And since many universities do not have either wherewithal or their own bogged down problems, therefore, AICTE started off with giving a model curriculum. And we never say that our model curriculum has to be used letter by letter, word by word, but every university is autonomous. They can certainly make amend changes, tweak with that as per the requirements of the region, as per the requirements of the vision mission of the institution, because some institution may have focus on research, they may have some courses which are relevant to that. Some may have more emphasis on employability, let them have courses which are more on basis of skills. There may be some which will, probably would like to create entrepreneurs, maybe courses on business development, idea to, conversion of the product, patenting, intellectual property. They may include such courses as mandatory courses and then go along. But nevertheless, there are certain things which are common. And all of us who are in education, we are all aware that we always divide, as far as engineering education is concerned. There are certain basics which are required, the preparatory courses before a student joins, whether it is in physics, chemistry, maths, biology, and so on, including English language and some other skills with that a student enters the program. But even in the first year, despite having the education in that, we also talk about courses in basic sciences, courses in engineering sciences. Then comes the professional core courses, electives of the discipline, open electives, which UGC has been talking about, what is known as choice-based credit system. But institutes like Indian Institute of Science or IITs have adopted what is known as this CBCS system right from inception. and everything is based on credits. You earn credits. And therefore, for every program, what should be the minimum number of credits is one question which often comes up. And also accompanied with that is the number of credits and the way we define the credits. Different institutions have different credit rating systems. One lecture hour per week is 1 credit, one tutorial hour one per week, 1 credit, 2 laboratory hours equal to 1 credit, or somewhere else the quantum of work that one has to do, or engagement between students and teachers also, like 30 to 14 hours a week. Please put your mics off, otherwise it disturbs everyone else. Our administrator must take control and then try to do that if possible. So I think these are very essence of the revision of the curriculum, which happens quite often. And there are many new emerging areas which are taking place. For example, now we talk about Industry 4.0. Then attached with that is AI, IoT, machine learning, robotics, blockchain, augmented reality, virtual reality. And every student, in order to become employable or to get entrepreneurial journey, they need these subjects to be taught. So if they are to be taught, the number of credits have to increase. But there is a minimum and maximum time limit which one has to undergo to get a degree. And it's around 4 years in engineering, maybe 3 years in science. And therefore, we cannot include more and more things without taking off something. And that is where the challenge starts happening. And then there are a lot of departments and many teachers who have been teaching a particular subject want that should be continued. It is so fundamental, how can you remove? And someone else who is a PhD from abroad with postdoctoral experience with some new topic which he has done in research, he wants that to be introduced. There are these kind of challenges which every curriculum revision have exercised. Whenever it happens, we have found that in every institution. And this challenging task we had given to Professor B. Ravi from IIT Bombay. And although we have a board of studies for engineering in general, which is headed by Professor Tiwari, who is the director of NITI right now, all of these people have, with their own rich experience, we want to create a curriculum framework and the drivers for empowerment, which will not only see the demographic dividend of the country to be utilized, used on one side, develop the economy, whether it is in terms of GDP growth rate and the human index in terms of ease of doing business, to ease of living itself, to the use of technology in education. How do we do it? There are several paradigm shifts which are happening in the entire education sector. How do we integrate? It's not a small task or a easy task for the committee to deal with all these issues which I have been raising. But I'm very happy that Indian Institute of Science, which is the torchbearer of one of the institution's early birds in mechanical engineering. Although I have been director of College of Engineering Pune, which is second oldest engineering college, but IISc is almost the same old. Once you cross 100 years, one with 100 years or 150 years does not make big difference. So IISc has contributed so effectively for giving leadership to the entire country for mechanical engineering. And why only in India? We have seen many of the deans of the engineering schools abroad in US and many other countries coming from Indian Institute of Science. So my congratulations for the great effort that Indian Institute of Science and all the faculty members of the institute of the past 76 years who have contributed. I remember Professor Narayan Swami, Professor Narsivan, who were gurus of my guru. So I think there were a chain of gurus who all molded us, and which has been possible to create a structure or emphasis on how the education has to be dealt with. AICTE on its part, I would just like to briefly tell 3-4 things which are very significant and important for what exercise we are doing. We started off with curriculum revision, but having incorporated new courses, new subjects, our teachers in ordinary second, 2-tier, third-tier colleges in small places, they have done their even MTech, probably PhD from not even IITs and IISc, and therefore to train them in the various new courses which are emerging, we have what is known as Atal Academy. ATL is AICTE's Training and Learning Academy. Through ATL Academy, we have been training faculty members in all the emerging areas. It is a 1 week full program starting from Monday in the morning till Friday evening. And there are lots of assignments given to faculty members during the period of this workshop. They have to attend and also give assignment, submissions like students, and only then they get certification at the end of that, which is used for their career advancement scheme, promotions. But the significant thing is during lockdown, we did not stop. And this technology platform, which we are now using for this meeting, similarly, we had more than 948 workshops, trained 165,000 faculty members in this one pandemic year. It has become a Guinness Book of World Record. Similarly, for empowering students, we have courses on various open source courses, open source software, for example, Python. In one single day, 24 hours, students prepared face recognition software using that. And that was 1.24 lakh students in another Guinness Book of World Record. So I think today, whereas face-to-face teaching learning process is very important because you solve your difficulties, you raise doubts and you argue, counter-argue. This is very important and significant. But because of pandemic, if that did not happen or is not happening at the current times, certainly we should go back to the old times and start being together, because human beings are social animals and we not only learn something from the classrooms, but there are many other engagements, social life, which is so significant for Homo sapiens, the human beings. And that's why we must go back to the old life. But till then, we are using the technology as much as possible in order to empower our students, our faculty members. We have another program which is called as a Student Induction Program of 3 weeks duration, and in which there are 9 modules which we have defined. These 9 modules start with the students knowing each other in a college or a new environment, to whether it is yoga, meditation, whether it is sports, whether it is different art forms like music, dance, drama, or whether it is eminent persons' lectures, or how they become empathetic, the importance of being human, that is very significant, and all the value system starts getting incorporated during the first 3 weeks of the institutional beginning. And if that happens, the next 3-4 years, whatever students remain in the college, whether it is in arts, science, commerce college or engineering, we have given away, and the students will become integrated with the institution. They gel with the institution. They start feeling one with the institution. They feel that it is their home. It is their, where they will be able to transform themselves. And once that comes into the psyche of the students or the DNA of the students, rest of the learning becomes very smooth. And this has been very, very fruitful in an era when student agitations in campuses have become order of the day. We have been able to take care of this through this simple program of universal human values, which are inculcated among students through this particular program of a student induction program. We have also an elective course on universal human values. Now we are making it mandatory, because ultimately, after all our graduation, when we go out, we have to live in the society. We have to live with each other. I think this principle has to be embedded into the psyche of the students. I think this is another area which we are doing. The third one, which industry often talks about, employability, and therefore internships are very important. In medical education, after your graduation, unless one practices for about a year as an housemanship in a hospital working with the senior doctors, you don't get a degree. But in engineering, all along, what we have seen is you just do all theoretical or at most some laboratory experiments in the class, laboratories, and then you become engineers. And we find that when they go to industry, they find something different there from the engineering institution. And therefore, 6 months of mandatory internships in the 4-year program, whether it is split into 3 summer vacations, or if the university curriculum permits 1 full semester, one can go to an industry, is another parameter which we have done. And more importantly, other than research, innovation has become the order of the day. How we change the products, how we involve in doing a modification which will not only improve the productivity on one side, less cost, and therefore, how do we make this happen? For that, innovative bent of mind is very, very important. And one thing which is connected with innovation is our examination system. Unfortunately, in our system from KG to PG, the examinations are all based on rote learning. Someone who is able to remember and then write that answer as is given in the textbook, they get maximum marks. Whereas students who have their own innovative mind and they write their own answer many times get less marks. And this is a problem from school teachers to the highest education. And that's why the examination reforms, which Dr. Ashok Shettar, who is going to probably speak on that matter, we have incorporated that as one of the important aspects, that how using Bloom's taxonomy, not merely rote learning or memory-based questions, which are also required sometimes, about 30% of them. The remaining 70% should be on understanding, on critical thinking, analytical ability, data analytics, creativity, innovation. If such question papers are set, a human being automatically becomes innovative, starts using left brain, right brain in right proportions, and then all the things which we do in the future would be useful to the society. I think I can go on, but I think time is a constraint, and I wish this particular 75th year of celebrations of Mechanical Engineering Department of IIC, present, former, all chairmen, my best wishes for this particular event. And out of this, certainly something, what we call Samudra Manthan, which is happening, we will get some Amrut, which we will all be able to make use of for transforming this nation into a new India, which our Honorable Prime Minister often talks about. Thank you. Namaskar.
Thank you. Thank you for sharing your insights and initiatives of AICTE. It's very nice to hear. And we are running behind the schedule. We have a recorded speech of Professor Arun Narasimhan of IIT Madras. It's for 8 minutes. And Alok, can you please run this now?
Yeah, sure. You can hear me, Professor Suresh?
Yes, I can hear you. You can share the screen. And, yeah.
Okay,
we
let
can
me
see,
know if...
Yeah, now we can play. Alok, we are not able to hear, so you need to turn on the computer sound when you share the screen.
I already did that. Just a second. Let me unshare.
Is anyone able to hear Professor Arun Narasimhan?
No.
No.
No, sir.
When you share the screen, there is an option you have to turn on.
Yeah. This time.
Can you play it now to see if the sound plays out? It has frozen, Alok.
Yeah, it's frozen. Please just give me 1 minute. Just 1 second. Just 1 second.
Alok, shall I give it a try?
Do you have that file downloaded?
Yeah. I'll just try sharing. 1 minute.
Okay.
We have a very tight schedule because to hear from all the distinguished people, we had to give very little time for each person. But I'm sure it will be exciting because
Yes.
a lot of you have great ideas.
Is my screen visible?
Yes, Navneet, it is visible.
Okay. Let's see how it goes.
Welcome all to this workshop. Share and brief some thoughts to open discussions to follow in 3 separate sessions. Coders need not have college degrees, that is in computer science engineering. That is the refrain we hear from Silicon Valleys nowadays. It is true to the leaders of that field, hailed as visionary tech leaders, quite a handful of them college dropouts, but phenomenal hard workers, so which will be forgotten in the seeming sarcasm, which this is not. When a booming industry in an allied, relatively recent subject promises riches without a college degree in engineering, a professional degree, we have been identifying them. What engineering should it advertise likewise? Can it do? Or as an alternate, should it take a look at what it offers as a college degree? That is the topic of this workshop. specific discussions on two broad topics. What is mechanical engineering work to be inculcated in students, and how the next day. Keeping the school of today large in mind, two aspects in themselves. Allow me to elucidate them from a personal angle. An engineer is a person who is not learned enough to be a scientist, skillful enough to be a craftsman, or clever enough to be a manager. But he is needed in every company to be blamed for the shortcoming of scientific theories, inadequacies of empirical methods, and unpredictability of personnel he is working with. May God bless them all. That was a quote from R.F. Tusky. Tusky was a Czech engineer, a Czechoslovakian engineer, who worked on time management concepts for varying organizations. That quote I took from one of the handwritten notebooks of my father. That quote is what set me to understand who I am as an engineer and what it is to profess an engineering field. My father became a mechanical engineer because he worked for BHEL Trichy, an organization that was adapted from Czechoslovakia, or that was adopted by Czechoslovakian engineering principles. So he grew as an engineer along with that company, which grew as a leading engineering firm today of India. But in his last year as a professional, he shifted to computer science, while I became a mechanical engineer, inspired by his notes. Today, my father is in his deathbed, literally and figuratively, a dying breed, perhaps, as I am unable to inspire my kid, who has just completed her school education and looking to join a college. I am unable to inspire her into engineering, any engineering, leave it penny. If I push, she is ready to go into computer science, precisely because the field doesn't demand a completion of a degree to envisage and sustain a successful career. And importantly, it allows hands-on experience about what is to come in future to her, right in her school days. And it promises her she can learn and join and participate in that field. It is not something she looks on or given to her by others as something beyond her grasp at her age. It is something, say coding in Python, that she can grasp in her school and become even a master at right out of schools. So the subsequent college education in that field promises a route to a career where she can participate and contribute, that is perform, rather than watch and do apprenticeship and hope to become only a cog in a wheel that she never could aspire to turn by herself. After all, for most of us, our college workshop in mechanical engineering, hands-on training, we did workshop training with this character. So the question I have as an engineering academic is this model of engineering degrees in specialized fields, ME, mechanical engineering, civil, electrical, etc., is this model stable in the next decade? More importantly, is it meaningful to have only such a model offered to today's? Should we, for instance, think of only a college degree that specializes in general engineering? The successful graduate can be absorbed in as many companies of varying specialities as possible and get trained in the specifics of that company or industries for her career. If that model is extreme, is to think of how to open up, so to speak, each engineering field to accommodate as much from other fields that offer a successful and enriching career, and make the budding student perhaps learn she could learn and perform as an individual engineer, an individual mechanical engineer, so to speak, in an organization that may not even be doing mechanical engineering. How to do this? As an university, a place to generate higher ideas that affect society at large, we may be tempted to unify our knowledge base just into 3 departments: a Newton department, a Maxwell department, and a Darwin department. But to make today's students realize the relevance of them in the context of today's professional career and an engineering education as a means to embark on that career is a challenge. That connects with the next topic of our workshop discussion: how interdisciplinary a mechanical engineering degree should be or should become. A final aspect is the mode of imparting such knowledge in today's society. We learned the hard way in the last 2 years about this. An educational institute is always a place where people interact physically and exchange their ideas. After all, the word academia comes from the grove of Academus, the grove where Plato and Aristotle walked, perambulated, and discussed ideas. This concept itself took a toll and is questioned now due to a pandemic. So how good is mechanical engineering education imparted totally in online mode, that is off physical interaction mode? This model may be relevant for today's conditions, but how relevant it is for imparting the education? That is another aspect for these workshops, to discuss the challenges of online mode of education of mechanical engineering, to discuss sustainable ways to use technology in the pedagogy of mechanical engineering. Let me stop here. I hope I have given you all some nucleation points to ponder. You may disagree or even disapprove, some or all of them. That should inspire your discussions for today. Let me again welcome you all, experts and visionaries in your chosen field of interest, to participate in this workshop, in this wonderful opportunity to formulate the future of mechanical engineering education as relevant to our country and the world at large. Thank you.
Yeah, we thank Professor Arun Narasimhan, who could not be here because of, as he alluded to, his father's health, but he recorded and gave this nice presentation. We thank him and for representing INE in this event. This brings us to the conclusion of the welcome session. Now we move on to the context setting session, where the committee members, AICTE committee members, will present the views of their discussions that we have been having meetings on Saturday afternoons for already five weeks. And I request Professor Ravi, who is the chair of AICTE committee, to talk about curriculum framework and drivers. And before that, actually, the session chair is Professor Munjal, who is a distinguished professor of our department. As Professor Aksabuddhe said, he is the guru of Professor Aksabuddhe and the guru for all of us. And I request Professor Munjal to chair this session. Professor Munjal.
Thank you, President Suresh. Can you hear me?
Yes, we can hear you. Yeah.
Okay. There are 5 speakers, 5 distinguished speakers in this section, which is called context setting. And unfortunately, we are running behind schedule, so maybe it will be just 5 minutes each. I'm sorry, everybody has to reduce it so that the later sessions are not inconvenienced. Okay, so we start with Professor D. Ravi. He's Institute Chair Professor in IIT Bombay, and he speaks to us on curriculum, framework, and drivers. Professor Ravi.
Yeah, very good morning to Professor Sahasrabudhe, Professor Munjal, all the gurus out in the room. It's a great privilege, it's a great pleasure to speak to all of us, all of you. Of course, we are all together here in this mission of trying to look at what should be the curriculum, and also partly pedagogy, but mostly curriculum. What to teach, we look at it first, and this is my responsibility here as one of the contributors to this whole thing. What are the basic drivers and framework for this this curriculum setting for this mechanical engineering for the future? Of course, we all have to worry about, are we really even, can we even predict? Because change is not only constant, change is, I think, even, I would say, accelerating, and it's getting unpredictable. We can't even say what's going to happen next year, leave alone next decade. But let me just try and do within next 3-4 minutes what we can give some kind of a pointers to what may happen. So next, let me put this first of all, because I think the primary drivers for curriculum, and we're talking about large number of colleges across the country, many of them in small towns. I think they're all looking for mainly jobs. And if you look at jobs, there is one way of looking at it in terms of technology and scale. So if you look at number one preference for most of the students will be MNCs, simply because work environment and of course the salary is there. Then, of course, they also look at PSUs and large companies like Mahindras and L&Ts, which also give fairly good, you can say, job security along with fairly high salaries. And then maybe they can't get jobs in these two, they look at MSMEs. There are, of course, exceptions, but I'm looking at the majority of them. If none of this happen, then they're also thinking about these so-called startups, which government is now pushing very hard. And next, let me look at some of the drivers from the government point of view. If you look at it, they're always worrying about how do we grow the economy, how do we distribute the equitable distribution of wealth. Manufacturing, which they want to push from about 16% of GDP to 25%, but it's actually coming down. A lot of people are getting out of jobs, and therefore creating more employment opportunities through entrepreneurial ecosystem seems to be the one of the major driving factors from government point of view. From industry point of view, they all know that if you want to survive in this major international competitive thing, China is almost supplying 28% of manufacturing output of the world, and India is just around 3%, 1/10 of that. So they know that continuous product innovation, process automation, supply chains being very flexible, robust, and they're moving towards agile, you can say, systems, agile workplace, work time, um, and it's moving towards, in some sense, contract employment. I also represent metal casting sector, and I know it's literally mother industry which supplies to all industry segment. And I can tell you that in most foundries, except for a handful of people who are permanent employees, most of them are contract employees. It's becoming like 20 to 80% contract. So on the other side, if you see youth, we're talking about those born around this 2000, just before, after that, their aspirations, their connectivity that they want to be on a work from home, workation, which is workplace vacation. And they're looking at this new way of life, which is called as a learn, earn, burn, and repeat the whole cycle. And they're turning to open resources like YouTube and Google for learning. Increasingly, companies are saying what we want is not it's not your degree that we worry about, it is what you can deliver is what we worry about. So I think we are looking at perhaps a new paradigm shift in even the way we train our youth to get into a productive economical jobs. And on the academia side, and we're talking about this large number of colleges, they worry about this infrastructure. They worry about financial sustainability, scaling up, because that's also financial. And that's driven by college brand and maybe the ranking of the college. That's why it's becoming very important. But I think all these are driven by how well the students are placed, and faculty increasingly are being looked upon by both management as well as students as not as information transmitters but as facilitators towards a new way of learning and so on. So next, if you see the monkey in the room, has it come up? All okay? No. There was one. Okay, I thought, yeah, that's what the monkey in the room, in my opinion, is that you see an increase, and I'm betting on this that we are going to see a large number of platforms on the net which will give short-term consultancy kind of jobs to a large number of people, which is called as gig work in the parlance there. And I think all the things which you see here in yellows and oranges may be driving people towards gig work, which could become the major driver for everything that we talk about in the next few years. Next. We also looked at the current curriculum of AICTE, and we have tried to give you some color code here, which you can debate a little bit up and down, but we try to divide into 4 buckets: science, technology, engineering, and a bucket which is humanities and management and all other courses as a professional, you can say, application of these things. And you see there's a fair distribution in terms of these 4 buckets. Next, if you see, there are also 2 things which you notice that total number of credits is about 160. And if you look at about 3 credits as a average, you're talking about 48 courses, about 40-45 courses, plus about project in 4 stages. And internship, as Professor Saraswati mentioned, very important part of the component. 6 months can be taken as one single semester or maybe 3 summers of 2 months each. But overall, one more takeaway is that if you notice this, there are fairly good number of science, engineering, and humanities courses. But if you look at information technology and emerging technologies, because later on you will hear from many other speakers, how do we get mechanical engineering students and students to mechanical engineering and make them more productive. I think unless we bring in a lot of advanced technologies, information technologies, I think we are in trouble, and that you see is not being reflected very well. Maybe it is hidden somewhere in the courses, but it has also to be explicit so students know that it's important. My last slide, next one, is about a framework. Pastor Aloke, if you can go to next. Maybe it takes time to reflect. So what we said is, let's see whether we can give a holistic education to mechanical engineers. We came up with this short description saying that mechanical engineering involves 4 kinds of things: scientific analysis, which can come from the science bucket of courses, problem solving, which comes from this engineering kind of bucket. Then you also talk about technology for methods and tools, and eventually applying the whole thing by integrating knowledge from not only within mechanical but also other disciplines. But if you look at the courses which are projected here, again, you can slightly argue whether some course should be in the science bucket or engineering bucket. But still, if you see, and this is what we need to discuss later, is this distribution right? Are the course titles right? Do we need to combine some courses? As Professor Saraswati mentioned, if you want to make place for some new courses, like if you see on the technology side, there's hardly an explicit course on, let us say, CAD/CAM or CFD or let us say, Industry 4.0, which could perhaps bring students to mechanical. They are kind of missing. Maybe we need to bring them explicitly. Also in the professional courses, if you see, it just says professional electives, but should we start making buckets saying technology sector electives or maybe management electives like quality management and project management, team management, things like that, and even project, and how do we bring entrepreneurship, innovation entrepreneurship into the whole picture, again explicitly. So this is more like food for thought for everyone to mull over as we hear other speakers into what could be the elements that we should worry about as we design the curriculum. And our team is sincerely going to be noting down. The entire session is going to be recorded. We look forward to coming up with something which will not only stand a test of time, but also we can be justifiably proud about and make a difference to society in terms of the next generation. But thank you very much for listening, and I'm looking forward to listening to all of you. Thank you once again.
Thank you, Professor Ravi. Our next speaker is Professor G.K. Anand Suresh. He's chair of mechanical at IISc, and he speaks on mechanical engineering temper. Professor Anand Suresh.
Yeah, thank you, Professor Munjal. I'll share my screen. And, is my screen visible, Navneet?
Yes.
Yes. Yeah, please go ahead.
I think 1 second. I think I need to redo it. Sorry, more slide things go bad. Good morning. I will make an attempt to tell you what mechanical engineering temper is. If you Google this, you will not find anything relevant. If you Google just engineering temper, you will get links for heat treatment of steel. Temper, of course, is a familiar word. Temper, with its roots in Latin, means a state of mind, a mood, and one's way of thinking, acting, and behaving. Scientific temper is used a lot today. Interestingly, one of the earliest uses of scientific temper was by Jawaharlal Nehru in his The Discovery of India. Nehru eloquently talks about the scientific approach as a way of life, a process of thinking, a method of acting. He says that the scientific temper goes beyond the domain of knowledge. It becomes an innate part of us. Let us shift from Pandit Nehru to Shah Rukh Khan to quickly understand what scientific temper is in our daily lives. Here is a scene from Ashutosh Gowarkar's Bollywood movie Swadesh. When the power goes off during the screening of a movie outdoors, the hero quickly turns the telescope towards the starry night sky to engage the disappointed village children. The scene gives me goosebumps every time I watch it. There is scientific temper in it. Curiosity, observation, reasoning are traits of a scientist. Seeing what is there and analyzing it and discovering the essence of science. What then is the engineering temper? It is creating what is not there, synthesis, making things and making them better. It is all about problem solving to improve things around us. An engineer creates things that benefit the society. India's most celebrated engineer, Sir Mokshamunda Vishweswaraya, emphasized serving the society through engineering. Today is the birthday of Nikola Tesla, one of America's greatest inventors, who electrified the United States of America. For him, invention is a prime activity of human creativity. Engineers create things. If looking at the twinkling stars and wondering what they are is the scientific temper, aiming to set up a constellation of satellites to monitor the planet is the engineering temper, as this young BITS Pilani graduate is doing. Awais Ahmad, the CEO of Pixel, embodies the youthful engineering temper of India. So, every man and woman with engineering temper would look at anything and thinks, how can I solve this problem of the society? He looks at the thing and wonders, how is it made? She looks at the thing and ponders, how can I make it better? Now let me tell you what mechanical engineering temper is. Engineering is much more than inspired invention. Engineering is rooted in scientific theories. Can engineering thrive without the theory? Theory and experience are of equal importance to the engineer. Theory without the experience is the foundation without the superstructure. Experience without the theory is a superstructure without the foundation. The former is useless and the latter is dangerous. This was driven into his students by Professor Kernot at Melbourne University in the later part of the 19th century. One of his pupils was A.G.M. Mitchell, an extraordinary Australian mechanical engineer who superbly exemplifies the mechanical engineering temper. Here are two of his works that stood on sound theories and contributed to the industrial practice of ship technology, hydroelectric power technology, automotive technology, and more. His tilted pad thrust bearings were marvelous inventions, but unlike the iconic electric bulb, it was much more than an invention. Mitchell did careful calculations after poring over Osborne Reynolds' work on lubrication theory. He did not stop where science or theory had stopped. Mitchell added his fertile imagination and keen mathematical abilities to make a perfect bearing for ship propellers, a nagging problem at that time. Mitchell's another contribution was in structural optimization. Mitchell continua are like Carnot cycle for optimal structures. Here too, Mitchell relied on none less than Maxwell's work on optimal trusses. Mitchell's celebrated paper of 1904 begins with Maxwell's name. So, engineering practice rests on great theories. Like Mitchell, if we have the mechanical engineering temper, we should inhale science and theory and churn all engineering inside us and exhale technology. I want to end with some food for thought today. Science takes a bite and leaves it, engineering chews it, and technology digests it. Thank you for your attention.
Thank you, Professor Suresh. Next, we go to Professor P.V.M. Rao, Head Design Department, IIT Delhi. And he speaks to us on hands-on experiential learning paradigms. Professor Rao.
Okay, thanks. So, good morning and thanks for this opportunity. I think my slides are visible.
Yes.
So, okay, I think one of the things which probably I wanted to cover is looking more curricula more from the student's perspective, often we have seen that many of the curricula meetings which happen across the country do not really involve students in a very strong manner when we sit for the curricular design. In fact, it is often said that in today's customer-centric world, every product and solution is designed keeping customer or end user in mind, except curricula, which is there. So I think it's good to have students as a part of that, and it's good to see that today we are joined by some of the students who are also part of this. Now, taking particularly from the students' perspective and putting myself in their shoes, we asked a lot of students a few years back, what is their expectation from a curricula? And we have also seen that there is some disconnect between faculty's expectation from a curricula and students. In order to bridge that, we thought let's go to students and ask. So first thing which came is that many of them said that present education system is largely dominated by lectures and examinations, which is probably what most of the curricula would consist of. Whereas there are also practicals in many courses, but many of them said that practicals have become a more procedural, where everything is kind of a pre-decided. You know what to do, what equipment, what data, what results, and what questions will be asked in a viva. So the cognitive and creative component of practicals were lacking. These are all what students said. And also people said that there is a heavy emphasis on knowledge acquisition, very little on knowledge application. And students feel key in today's connected world, knowledge is freely available and they are more hungry for knowledge application activities. Next. Next. And also it is generally seen that there is a heavy domination of head over hand, which we see in a lot of curricula these days. And people also, many of the students also mentioned that they would like to connect with the real world through curricula. Often students study subjects without actually knowing where will they be applying these concepts and how will this be useful in a real world. So bringing a real world connect to the classrooms and probably all the curricula which we designed was highly desirable. That's what is one of the comments. And people also said, many of them said, when students come, they have certain aspirations and they see that what is taught and what they study, they are not able to relate to their aspirations, and how can we bridge this particular gap. And also many of them said when they don't see these things happening in the very first semester, they lose interest and it becomes very difficult for them to come back. And we have seen this is a situation across the country, whether it's IITs or NITs or other colleges. An average student probably needs to be more excited about engineering education than what presently it has. Now, so there were also some experiments which are done over a period of last 8 to 9 years to at least change curricula and bring maybe 10% of the courses, probably what students would like to have, rather than everything being decided by a faculty. And what came out is that students showed a lot of interest in three types of activities. First is that experiential learning, learning by doing. A lot of learning happens learning by doing. And there are certain courses which many universities and institutes have introduced now. And also a collaborative learning. Students feel that once they join an industry, it's always a teamwork, whereas they don't get an opportunity to work in teams, particularly that is something which they wanted so that they are employable from the day one if they have an experience of working in teams. And also a social learning. How do you connect with the real world problems and how can engineering particularly address these real world problems? These are the three aspects where a lot of experiments were done in many colleges. I would say all types of colleges, tier 1, tier 2, tier 3 private colleges. And what happened as a part of this experiment is that students came in large number for such courses and the class enrollment swelled. I'll just give an example. When we introduced similar courses in IIT Delhi, there were classes where the enrollment went to something like 1,500 for such courses. We didn't have a hall to accommodate so many students, and we had to say no for many of the students. But students came in large numbers. And in some courses, which probably they like most, students put voluntarily additional effort going beyond the expectation of a teacher. And I think that shows the ownership of a students to probably an interest in these courses. And students were also ready to learn beyond curricula, whether they get credits or not. And many of them said, even now, some of the recent graduates keep writing that some of these courses were very professionally and personally satisfying. And good thing is many students stayed back on the campus beyond their graduation. At least I know about 40 such student cases who stayed for an additional year or two to continue their education process beyond their graduation. And we have also seen that many students took the role of job creators than job seekers, which is also one of the purpose of our engineering education. Now, the whole idea of bringing these two slides is that it's not probably possible to change the curricula radically in one probably curricular revision. But the idea which we are trying to look at, is it possible to bring at least about 10% or 15% of the curricula, which is more experiential, more collaborative and social, where probably students own their courses and the education can be made more exciting for students. Thank you.
Thank you, Professor Rao. Our next speaker is Dr. Raj Anpriya. He is a director at CMTI in Bangalore, and he speaks to us on mechanical engineering, SWOT, and gap analysis.
Good morning. Thanks for the opportunity. Basically, as Professor Rao talked about from the students' perspective, but I will be talking in perspective of employers and how employability could be enhanced in the industry and R&D establishments. The next slide, please. If we summarize the activity which mechanical engineers get associated in their profession is they're involved in design of a product, machine, systems. Maybe some people would do little bottom layer like drafting. And some group of mechanical engineers will be involved in realizing that concept, realizing the drawings to a product that essentially involves process design, selection of appropriate manufacturing process, and also involved in consultancy and supervision of manpower, that is the workforce. Then group of mechanical engineers involved in testing, assembly, and then performance testing at component level or at the system level. And then some mechanical engineers involved in the services at various industries, and also testing as per the standards. There are specific standards. Some are product specific, or some are system specific. Then group of mechanical engineers also get involved in the research. Definitely, they are associated in developing a new product, so for solving a specific problems. Then the process and production practices like what we call now Industry 4, all these production trends. And then they also look at deployment. Of course, it is not still it is remotely connected, but yes, there is a deployment of the solutions in industry is also part and essential component in the research. And then last but not the least, there are a good number of mechanical engineers gets associated with the teaching, starting like fresh graduates, mechanical engineers. I'm not talking about masters and PhD. Even with undergraduate degree, these are get associated as a faculty of polytechnics and lab assistants or technicians in engineering school, and also the faculties of vocational training institutes and other skill development centers. But if you look at what is expected from the mechanical engineers as a hiring manager, what is look at is how is innovative and competitive enough to find a solutions for a specific problems, and then is experience and exposure towards design and developing a products and process using advanced tools like CAD, CAM, CAE, all those becomes an essential components or the skill sets. Then computer and analytical, numerical, analytical skills of an individual. These are more hardcore engineering courses, skill sets. But apart from that, yes, mechanical engineers also need to have the ability to plan, prioritize his work, meeting a deadlines, taking a pressure, because those who are in production, really they are subjected to severe pressures. And then also the professional responsibilities like cost, value conscious, because productivity is not alone will not survive, will influence the survival of the company. So cost conscious, then awareness of social, culture, environmental, health and safety. Even health and safety of the laborers itself is the responsibility of the supervisor. Then, of course, detailing, exercising its judgment, then accepting the responsibility. But in this current growing trend, so now it is also expected that mechanical engineers notes from like skill sets like starting from coding to correlating or relating to the people. So that is communications and all matters. But if I look at that slide, invariably mechanical engineers involved in this, in engineering of systems and products. So definitely it is expected to have the knowledge of all those 5 Fs, and that 5 Fs will come with strong fundamental engineering foundation. But if you look at what is lacking now in the current engineers, so the practical based learning is completely missing in the engineering school. I mean, even many universities have compromised the laboratory classes or the workshop classes. But as a result, what has happened is if the graduate engineering students, I'm not blaming anybody, but this is what the fact. If we give the stapler and ask the students to identify how many parts are there, what is the material, what is their similarity, what manufacturing process they use, and what are the accuracy or the tolerance requirements. So at least more than 50% of the students doesn't have any idea because they are not taught. Then as a result, the students cannot be able to appreciate when they join the engine industry or when they take up the professional, that is what are the aspects associated with respect to 4P of the value chain. The 4Ps are product, process, people, and production. This is because our classes, as all we know, is theoretical classes of 1 hour 45 minutes, but this is one report, is not my statement. So in a classroom, student can able to have a kind of attention only for 10 to 15 minutes. So naturally the challenge for the faculty, how to enhance this into a 35, 40 minutes of class. So naturally the practical based learning, and also the classrooms has to be kind of practical cases has to be brought to the classrooms. The faculty has to get involved in some way so that classrooms can be made more interactive. These are like, everybody knows that I hear, I forget, I see, and I remember, I do, I understand. I think this is mechanical engineer course education definitely driven by this. And if I look at the current practices, what we have right now, of course, imparting practical learning in the engineering college, particularly mechanical engineering department, is difficult because high capital investment is required. So many of the type 2, type 3 colleges doesn't have even milling machine in their lab. And then faculties, there is no mechanism of faculty specialization. Many of the type 2, type 3 colleges is like manufacturing course is taught by a faculty who never operated a lathe. So that is a kind of situation in the faculty expertise. And then faculty changeover is another issue in the type 3, particularly type 3 institutions. And the internships now, though many universities have an internships, either they are driven by alumni or many cases as a business house. I'm aware of some such systems in Bangalore. So students will go and pay 25,000 rupees. You will get a certificate of an internship. So that is a kind of mechanism. That is another challenges. Then if you look at academy, R&D, industry collaborations, yes, the students wants to come to R&D labs. R&D labs also wants students, or CPSC wants to students. But there are issues with respect to taxation itself. There are some policy issues. And then the self-sustainability is another issue. So naturally, these industry and R&D collaborators look at, it is not my responsibility. These are all the few challenges, I think, during our committee discussion and also involving some of you are already there here. So it was thought that, okay, can we have BE, BTech courses, undergraduate courses, 4 years plus 6 months compulsory, like what we have in medical school, medical education. Definitely this will help to MSME, employability will definitely improve. But globally, BS in engineering is 4 years degree, adoption is an issue. So that is within 4 years, we need to offer this mechanism of a kind of compulsory training in the industry environment. Then can we have all the courses built in with the practical components instead of 3 credits? Shall we go for 2 plus 2 credits, 4 credits kind of thing? And second is compulsory training for the faculty. I think prior to take up the teaching job or after taking a job, that has to be discussed. And of course, there are now, as Professor Rao mentioned, IIT Delhi and all the practice. I think some mechanism for allowing students to earn credits by outside classroom. So this is what we wanted to explore when we go to the breakdown rooms. Thank you.
Thank you, sir. Now, our last speaker in this session on context setting is Dr. U. Chandrasekhar, Program Director, Wipro 3D Bangalore, and he speaks to us on outcome-based education. Dr. Chandrasekhar.
Good morning. Am I audible, sir?
Yes.
Yeah. Thank you very much for the opportunity. For the next 4 to 5 minutes, I'll briefly cover the essential of outcome-based education in the context of mechanical engineering. And while covering this, I'll bring in the perspectives corresponding to academia, R&D labs, and definitely industries of which I'm a part now. As we have seen, the configuration and functionality of mechanical engineering systems have undergone definitive changes over a period of time. Traditionally, the mechanical systems were comprising of pure mechanical or machine elements and electrical elements. During 1980s and 90s, we saw a wave wherein the mechanical systems got integrated with electronics, and we saw ubiquitous usage of embedded systems. And if you scan the contemporary mechanical systems, what comes to the forefront is the feature of smartness and connectivity. Whether we are talking about a state-of-the-art Tesla car, which can drive in autonomous mode, or we are looking at the new models of the refrigerators which are used in the domestic context, we can see IoT enablement, connectivity, and smartness to take decisions and respond to the needs of the environment. With the cognizance for this kind of a paradigm shift, now let's look at the trends in outcome-based education. In fact, for past 2 decades, the outcome-based education or OBE models have been fostered throughout the world by various national agencies and within India, very effectively by the National Board of Accreditation. What is very heartening is the faculty centricity has given way to student centricity, and the attributes of the graduate engineer students are measured through various means continuously now, corresponding to skill set, knowledge, as well as, in some cases, attitude. Indeed, the momentum created by the OBE models has encouraged the institutions to move up from the ladder from the lower order skills connected with remembering and understanding to higher order skills. Now, let's just pause and look at the higher order skills, evaluating and creating. If you keep them in the forefront, we can quickly understand that refining the contents alone cannot change. It can change to a certain extent, but equally emphatic is the importance of the need in the teaching learning method and explicit approach which needs to be integrated into the system in terms of creating things and making sure that the degrees which are earned by the students remain industry relevant. So if you scan at the practices of the industries in the current context, whether we are talking about hydraulic systems, earth moving machinery, thermal systems, medical devices and the mechanisms, there is a big difference compared to what was happening about 10 years ago. We can see the predominant usage of the software solutions in some of these cases, and it's not a must that the fundamental knowledge has to be explicitly employed in some of these contexts. So can I go to the next slide, please? Can I have the next slide, please? So what I did personally in association with a few autonomous colleges, few technical universities, and also affiliated institutions were series of programs. You can call them workshops or credit courses or small internship-oriented programs. I think I have got more than 2,500 students during a period of 7 to 8 years through a model called CDIO, Conceive, Design, Implement, and Operate. The acronym is CDIO. The primary idea is to facilitate the efforts of the students in applying their knowledge for doing some things. As Professor Rao mentioned, this experiment can consist elements of collaborative learning, social learning, and experiential learning. And originally we tried with the mechanisms of flapping mechanisms for the ornithopters as the objects that need to be created by the students right in the first semester. Then we tried with the topology optimized steering knuckles for the electrical vehicles. And very recently, after developing an emergency breathing system and for Wipro 3D called EBAS, we developed a pedagogical model with the focus on the mechanical ventilator. And we encourage the students in terms of employing the elements of design optimization and FEM analysis, 3D printing, and in some cases control elements for optimizing the system, its performance, and also making sure that it can deliver the necessary functional need. So fundamentally, what we have seen in this case is greater involvement of the students, propensity of the faculty as well as the students in terms of employing whatever functional knowledge they have got into realization of socially relevant systems. And we have definitely seen that AICTE has taken lots of proactive steps in the recent times in giving the latitude and freedom to the institutions in terms of configuring several courses beyond the foundational courses as the value-adding courses. So these elements can be integrated while the frameworks are being finalized by the institutions and the policymakers. And definitely all these things will support the outcome-based education models in the country in terms of making students as the creators of socially relevant systems. Thank you.
Hello. Thank you, Professor.
Thank you, sir.
Yeah. So here this session ends, and we are already running behind schedule. I don't know, Professor Suresh.
Professor Munjal, please summarize. Yeah, we want to hear your words as well. Yeah.
Yeah. Okay. I just like to tell you that what really comes out is that what is needed is, to make mechanical engineering or like any other engineering more market friendly. In introducing more design courses, project-based learning, machine learning, artificial intelligence, automation and robotics, etc., may revive interest in mechanical engineering and improve the employability of the mechanical engineering graduates. Encouraging entrepreneurship will make our graduates generate jobs rather than look for a job. This requires a change in our approach to teaching. We should encourage self-study, design exercises, open book examination, etc. So this is generally the thing that comes out of this. And in particular, I'll just like also to point out that, some couple of things that were said that's very nice, in health science and Excel technology. That was very nice. And then, the real world connect needed, knowledge application needed, collaborative learning should also be encouraged. And again, product engineering and design, process design, practice-based learning, etc. So what really finally comes out is that we really have to make sure that the students enjoy, they feel nice at the end of the day, and then not just look for a job, look for more challenges for themselves and come out with something that society needs. I think I'll stop here. Professor Suresh, you can go with the next session, please.
Thank you, Professor Munjal, for conducting this session. And I think we caught up on some last time as well. Thank you for sharing your thoughts and summarizing. This concludes the context setting session for this workshop. Now, next session is Distilled Thoughts workshop, for which the chair is Professor Pradeep Datta, my dear colleague here in the department. Pradeep?
Yeah, thanks, Suresh. So we will quickly move on to the next session, because as we are, also trying to reduce the time for transition. So this session is called Distilled Thoughts, and we have 10 distinguished speakers. Of course, it's not we are not doing justice to the distinguished speakers by giving only a few minutes for them to speak, but our speakers are so eminent that their words of wisdom are so powerful that even with a few words they can nucleate thoughts in our minds which we can think about and come up with right kind of suggestions and during the rest of the day. So I would like to request our speakers to restrict the time of presentation just with a few words of wisdom. And I would like to begin first with Professor Amitabh Ghosh, of course, who does not need any introduction, and he'll be speaking on science as a foundation for mechanical engineers. Professor Ghosh, please.
Yeah, actually, Professor Ghosh has pre-recorded, actually without words, is very eloquent, as you will see. Alok or Navneet, can you please share the video?
Yeah, I will share this. So
With
just
sound.
a quick word. This is Alok. I will be the admin here, and I will be sharing all the slides, and I have been sharing them. Now, there is always a small delay between what I share and what you see on your screen. I am monitoring everything on two computers. So if there is something wrong, I will get to know. But when your slide uh, portion comes, you just say next and I will move on to the next slide. There might be small delays there. With that, I will now share the screen and with Professor Ghosh's presentation. Navneet, the sound is not playing on my computer still. Is it possible for you to take this one?
Yeah, sure. I'll just share my screen. Can you unshare?
Yeah, just 1 second.
Yeah, thank you, Alok and Navneet for presenting it, and thank you, Professor Ghosh, for the inspiring knowledge, pathway to modernization. I would like to invite the next speaker, Professor Samir Khandekar of IIT Kanpur. Yeah, Samir, please.
Yeah, good morning, everybody, and thank you very much, Dr. Datta, for giving me this opportunity and all the organizers. So today I'm going to talk about the teaching and learning ecosystem in the context of mechanical engineering. Next slide, please. Time is limited, so I'll keep it brief. So the background is already set, actually. I'm thankful to all the speakers in the before me. So basically, if we see the history of mechanical engineering in the last 300 to 400 years around industrial revolution and post-industrial revolution, we see that, we started with the phrase like "we turn wheels." That sentence could describe mechanical engineers well. So anywhere some wheels are turning, we were there. The mechanical engineering art was there. Now this art has come a long way. We say that we also turn wheels, because the canvas of mechanical engineering has gone so vast now that we are practically everywhere in every field of societal activity. So we are expected to practically do everything, as the previous speakers from the industry have also delineated, towards developing a socially useful product, starting from ideation to manufacturing all the way to the marketplace. Now, we must understand and appreciate the thermomechanical environment in which the element, product, or the system or the subsystem must function, and also the various forces or potentials which affects its operation. So this is also part of what we should teach to the students. And the focus overall should be on functionality, efficiency, durability, aesthetics, and safety. So now, with this context and background, what we should also understand as teachers or an academic institution is that the society is seeking solutions. It is not seeking technology, in a sense that a housewife, is looking for a solution for a clean stove. She is not suggesting a technology. Technology is what we bring in, but the final thing, what we need is that this understanding that the mechanical engineers in the society, in the industry, they are actually working for a solution. Okay, so any teaching and learning ecosystem must respond to these expectations, and therefore the young minds must not only be groomed in the fundamentals of the art, which we will anyway do through the process of our curriculum development, but also the academic institutional environment and the ecosystem should be such that they appreciate the fact that technology cannot remain isolated from the society and, in the modern context, the environment. I think if we are able to give this thought process through our curriculum, through our activities, through our co-curricular activities, then I think the teaching learning objective of a mechanical engineering curriculum is actually fulfilled. Next slide, please. So in this context, we must understand also that what are the skill set requirements for the generation next. Now, this generation next, is going to be in a paradigm which is going to manage complexities. The systems are becoming more and more complex. We have moved a long way from simple prime movers to a very complex set of equipment, which has control, which has electronics embedded, which has so many safety, environmental aspects. So everything is going to be complex, and that is what they are supposed to mind. Then another thing which is important for the next generation is critical thinking, because every solution, it's a very well balanced ecosystem in which these products have to operate. The society is becoming more and more knowledgeable. The expectation from the society is becoming higher and higher. People are becoming more aware. So critical thinking is part of our process through which we have to provide this to the students. Creativity and innovation, I need not overemphasize. The context has already been set that unless we inculcate innovative ecosystem, the next generation is not going to be employable. And then the most important thing is the man-machine co-working environments. I think even this platform right now, which we are using, is a very classic example of man-machine interaction. We are interacting with each other through a very complex, system of hardware and software, and also, this platform. So the concepts of AI, emotional intelligence, artificial intelligence, machine learning, IoT, and big data. These are the names which are coming in, and the mechanical engineering teaching learning ecosystem must respond, to bring elements of these next generation skill sets into the curriculum, into the 4-year program. Now, so how do we do that? More and more things we have to induct, and the fundamentals cannot be left behind. So this is the big challenge which any curriculum, development committee or think tank faces. So the idea is we have to bring down to essentials. We cannot cover the entire spectrum, which is very clear. The spectrum is very vast. It's a big canvas, and therefore we cannot cover everything. So which means that we have to be nimble, and the importance of teaching how to learn new things, is actually more than ever felt now. Rather than teaching everything, we need to teach them how to learn new things, and that comes on many occasions through project-based learning and things like that. The second thing which I think is missing many times is how to interact with the environment through the art which we are learning, which means that if the student can see sitting in a room, in his kitchen, in his study room, in his hostel room, in his playground, if he can see things and appreciate that, yes, this is what I have learned today in the classroom. The fluid mechanics is there while taking bath. Heat transfer is there while cooking. Okay, there is dynamics in playing football. Okay, so this connect is something which is missing, which I feel very strongly. That we can connect to the environment through the art, and if we can appreciate, the students can appreciate, then I think our objective of teaching learning is fulfilled. Then the other thing is, conveying universalities of ideas. Even today, people believe that, students think that heat transfer is a different course than fluid mechanics. They look at it differently. They see that there are two books, but then the universal ideas which connect them, this needs to be appreciated by every teacher, and if you do that, then the analogies between electrical sciences, mechanical sciences, economic sciences can all come alive, and the equations which connect them with the commonality of the equation, the universality of the ideas. So this compartmentalizing, has to be somehow challenged and broken. Transport phenomena, for example, the art which I teach, if you universalize it, then it becomes so much more interesting, because then when he's doing basic electrical engineering, he understands that this is connected to what was done in the heat transfer course, for example. So this is something which is important in the teaching learning paradigm. And then, of course, hands-on interactive platforms, tinkering, DIY, internships, interdisciplinary group project-based learning, which already has been talked about. Because at the end of the day, our student has to go to the society, and the society is a complex amalgamation of several different ideation and ideas, and the product has to be then successful there. The last point which I'm coming to is the digital world, the way the digital world has affected us, all of us. So the question we should ask is, why should a learner come to the class? What is the value addition? Because there is so much of material available already on the internet. What are we as teachers giving them which excites them, which creates kernels in his mind which are not possible through the internet platform? So this humanness, which makes art exciting, which connects, which helps them connect different things, this has to come through the teacher. And I think that is very, very important. And this human connect, when I can see the eyes of my student and respond my next sentence by taking into account the class, is what is needed. And there is where the teacher comes in. And that is what we have to sort of also inculcate through the various AICTE programs, for example, these aspects of how to connect with the students. And finally, I think our art cannot remain isolated from the environment, ecology, and sustainability. So this is something which has to be ingrained in the ecosystem of the academic institution in all teaching learning paradigms. And therefore, in this context, when there is a committee who is looking after the new curriculum, is it time to reorganize the mechanical engineering academic compartments? Is what we should look at. How to give universalities of ideas, And last but not the least, academicians tend to be not nimble. I think this is the time when, we always say, Shakespeare said, I can teach 20 what is good to do, than to be one of the 20 to follow my own teachings. So this is something which is absolutely needed at this hour, that we have nimbleness in the system, which allows flexibility, which allows innovation, which allows, not only linear thinking, but also lateral thinking. I think we have done a post-industrial revolution. The linear thinking got a lot of importance. We have come to a stage with linear thinking, but there is an element of lateral thinking, because societies are complex and we must serve the society. Thank you very much.
Yeah, thank you, Professor Khandekar. Our next speaker will be Professor Rudra Pratap. He is now at Plaksha University. And, I would request all the future speakers to keep an eye on the time, because you are speaking important things, no doubt, and it's very, very interesting. But we are running short of time. So yeah, Professor Rudra Pratap, please.
Thank you, Pradeep. It's humbling to be part of this group of thought leaders. I'll try to be within 5 minutes, Pradeep. So, lot has already been said. It's not that we are the only generation who is thinking about change in education. This has been the case all along in academia, but it does help to take a look at the history, as Suresh had pointed out, and see how perspectives have changed. We are always debating between these two extremes of hands-on and theory. So if you look at the history of engineering as such, which is a large part of it is history of mechanical and civil engineering, 1750 to 1850 dominated by European schools. Those were the days of apprenticeship, and the most theoretical course used to be surveying, that kind of thing. From 1885, the American schools started dominating, and all the way to 1985, almost 100 years, there has been, over this period, there has been a gradual shift from workshops, hands-on, to lectures and theory. And this probably started in 1894 with Professor Thurston at Cornell. Cornell was one of the land grant universities in US. Actually, Cornell and MIT were the only two private schools in the land grant. All others were state schools. So from there, this initial batch of European scholars who had arrived in US, Westergaard, von Karman at Caltech, and Timoshenko at Stanford, they brought in a lot of rigor, a lot of theory, and slowly the shift started going towards lectures and theory. Next, please, Alok. So the guiding principle for lecture-based teaching has been that information was not readily available, okay? And therefore it had to be dictated and copied. This is why we move towards lectures and theory, okay? Next slide, please. Next. But now the big churn now is about, should we go back to hands-on, as you heard all speakers saying that experiential learning is what clicks with students. So now we are trying to again swing back But there is a big change. And the big change is that now the foundation itself has changed from what used to be more hands-on in workshops to hands-on on digital technology, because digital technology is in every aspect of engineering today. And a new science which has emerged, which we must take note of, is the science of learning. Carl Wyman, who is a Nobel laureate in physics, but has been dedicating his life after his discovery of Bose-Einstein condensate, proving that experimentally. After that, he has spent all his time about learning science, and he's by far probably the biggest contributor to the science of learning today. So based on what he has been doing, the learning itself or teaching is going to be extremely different today. And these experiments are on everywhere. So next slide, please. So because it is called distilled thoughts, I bring to you distilled thoughts of 50 very experienced educators from all across the world who have worked on this curriculum. This is what we are trying to implement at Plaksha University, which is an upcoming university in Mohali from this fall. So this is the freshmore curriculum, or the first 3 semesters, freshman and sophomore. And as you can see here, the first semester courses, so there is a Innovation Lab and Grand Challenge Studio where you do projects all along, all the time. And okay, so my time is up. That was my timer. So in 1 minute, I'll summarize this. So you can see critical thinking and scientific reasoning, engineering mathematics in action, fundamentals of computational thinking, foundations of physical world. This is all physics, chemistry, physics and chemistry, all of it, physical laws, design thinking. This is first semester. This is all first semester courses. Second semester, reimagining technology and society, mathematics of uncertainty, that is probability and statistics, object-oriented programming and data structures, nature's machines, human beings, insects, animals as machines, fundamentals of microeconomics. And then last semester, the third semester, the ethics of technological innovation, mathematics for continuous systems, data science and artificial intelligence, intelligent machines, and foundations of optimization. This is the distilled thought of 50 educators from across the world for first 3 semesters. This has been the work of 2 years of churn of experience from different people. Thank you, Pradeep. That's all.
Yeah, thank you, RP. We now move on to our next speaker, Dr. A. Raghu Upadhyay, is from Jain University. Title of the talk is Needs and Ways to ITify Mechanical Engineering. Dr. Upadhyay, please.
Thank you, Dr. Pradeep. Good morning to all. I'm indeed very happy to be here with you all today, and I thank Dr. Suresh and Dr. Ravi for the invitation. I'll put up the video if you don't mind. To this community, I don't need to emphasize the fact that a strong core engineering sector, in particular mechanical engineering, is fundamental for national development. This assumes further importance in the light of the country's Atmanirbhar Bharat Abhiyan, a self-reliant nation with innovative technologies which are specific to the needs of the country, specific to the needs of our nation, not somebody sitting somewhere else, whether indigenous products or processes or systems with multiple devices and processes. But as a member of the academic senate of VTU, I was saddened to see that many colleges under VTU in Karnataka, and in fact all over the country, were reducing the student intake considerably in mechanical engineering and related branches from 180 to 120 and sometimes even 60, or even closing them down completely. One does not need to go far to find the reason. This is driven by the market forces, obviously, which are influenced by the high employment opportunities in the IT sector, large number of jobs, high salaries, etc., coupled with physically easier jobs in a comfortable environment. But there are many IT minded in the younger generation who are still interested in the core engineering sector, provided we make it interesting for them. To attract them, we need to ITify mechanical engineering education, keeping in tune with the times. That is the fourth industrial revolution, exemplified by the Industry 4.0. In my opinion, it is not the computer science graduates, but hardcore IT minded mechanical engineers who are better equipped to address the emerging needs of the industry for ITification. This involves, on the one hand, efficient use of IT for jobs on hand, whether design, manufacture, testing, robotics, supply chain management, MRO, market management, etc. And on the other, innovative designing of mechanical systems with embedded electronics hardware and digital software, facilitating effective adaptation to IT, information technology. This is also in tune with the national education policy, which stresses on multidisciplinarity. But how do we go about ITifying mechanical engineering education? The answer, according to me, lies in digitalization of mechanical engineering. What does it involve? Let us take a look. Firstly, in design, whether a product, a process, or a system, the byword these days is the digital twin, which is the replica in the digital world of a real world system with all its attributes. It is predominantly data driven and IoT enabled. And what does it do? It proves your design or process completely in all its attributes before you commence its manufacture, if it's a product, or implementation, if it's a process, leading to improved performance and in efficiency, and also cost and time saving. The efficiency can be in energy, environmental impact, or in economics, or in other ways. The next is industrial process automation. This may involve manufacturing, industrial robotics, supply chain management, MRO, market management, and others. And this involves the use of artificial intelligence for intelligent predictive designs, data science to manage large amounts of data like measured, control data, or external input parameters, cloud-based high-performance computing, and smart industry, which is adaptive and flexible. I may quote Professor Alan Robinson, head of Mechanical Engineering Department of Carnegie Mellon University, who said, the emergence of data science has increased the number and variety of job options for mechanical engineers. They can now combine machine learning with engineering to address a wide range of formidable problems from water desalination to gene expression. To make sure that I am not talking in the air, I looked at what others in the world are talking about, thinking, and doing. There aren't too many, but there are a few examples which are just representative. At the Metropolitan State University of Denver and at MIT USA, course on direct digital manufacturing, of which additive manufacturing is a major constituent. At the University of Buffalo and the State University of New York, 9 courses titled Digital Manufacturing and Design, Digital Thread, Components and Implementation, Advanced Manufacturing Process Analysis, Intelligent Machining, Advanced Manufacturing Enterprise, Cybersecurity in Manufacturing, Model-Based System Engineering, and Roadmap to Success in Digital Manufacturing and Design. Another important area of importance is mechatronics and robotics, which involves sensors and actuators, controls and technology, and printed and flexible electronics. There are courses elsewhere relating to advanced applications like hybrid vehicles, green and sustainable technologies, autonomous systems, prosthetic devices, etc. in biomedical engineering. On advanced interfaces, at the University of Washington, we have additionally augmented reality and virtual reality, data science and machine learning, IVHM involving diagnostics, prognostics, human-machine interaction, self-assembly, manufacturing, photonics, etc. In India itself, I saw that we have courses on DM, that is digital manufacturing and digital technology at RIMT with this collaboration with Siemens in Shastra University in Tanjavur and Symbiosis Institute of Technology in Pune. And also there are suggestions from IIT KGP, IIT Bombay and other IITs. And country-wise, I saw a lot of interest in the European Commission, in Germany, in Russia, USA, etc. To conclude, I must say that the process is still in its infancy. but is projected to a high potential to make disruptive changes leading to great benefits to the industry. You must aim not to be just a part of it, but to be a major driver of this transformation. Thank you very much.
Thank you, Dr. Upadhyay. We now have a distinguished person from the other side of engineering education, that's the industry. We have M. Lakshminarayan, Chairman TVS Automotive Systems, to speak on mechanical engineering employability skill set. Mr. Lakshminarayan, please.
Hi, good morning, everybody, and I hope you're able to hear me.
Yes.
Thank you. I have not prepared any slides. I am a part of a small team that works on a weekly basis, along with Professor PVM Rao, along with Subramaniam in Carnegie Mellon, and also Shyam Sundar in Yale, apart from Professor Kale. You see, one of the things that's concerning all of us, and I've been a practicing mechanical engineer. I started my career with, I'm from IIT Bombay, started my career with Tata Motors, then was with Bosch. I was the managing director for about 8 years. Then I started Harman in India. So my spread has been from machine tools to automotive engineering to electronics manufacturing in Harman. Whenever I've been trying to take in students, and therefore I am now talking from the perspective of an employer. Now, we had our colleague talking from Wipro, who has been also working very closely on certain issues relating to employability. And of course, the plethora of presentations that have been made this morning, which is terrific. I would just, for want of time, I would just like to leave some 2 or 3 thoughts. What is happening is that most of the students who are coming out of engineering colleges, as they're coming out, I think everybody looks for, now I'm not just talking the tier 1, but the tier 2 and tier 3 colleges. All of them obviously are looking for employment. More often than not, we land up as source code writers because that's a very good mode of employment. But when we want to go deeper into either 2 frames, one is academics and the other is practicing engineers, it takes almost 2 years by the time we are able to get a person to work on a solution in a problem as far as industry is concerned. I will not be able to talk much about academics because I'm not very much involved in it. What we are trying to look at in our group, which we meet weekly, is what is it that we can do in order to ensure that the orientation is towards the 90% of the requirement of the industry. And especially at a time when we are talking in terms of growth of the Indian industry being free from China or whatever it is concerned, this is where we want a person coming out of the college, if they are able to get on to the functions. Now, it is a 2-way process. I will not essentially talk that only it has to be done by the academic institutions. We've been talking for a very long time of the industry institute interactions from various industry associations. But I do not believe that we have really gone into a very mature level of doing the same. Therefore, if you have a look at what is wanted, I think it's a question of ability to understand what is really the nuances in designs and try to bring in the new technologies that are possible to be inculcated in the system in the industry. We talked about digital engineering, which is going to be the order of the day. We, of course, CAD, CAM, CAE, etc., are all becoming accepted as norms in the industry. Last but not the least is our ability to find out how do we really go into the depth of manufacturing and manufacturing engineering. India has got teeming millions that needs to be employed. Most of them are trying to go to the service sector, but we need to go into the manufacturing sector and add product valuation. At the end of this whole session, my main idea, and thanks to Dr. Rao for inviting me, is I really want to understand what academics are doing. I'm a little bit away from it now. And with all the presentations that are made, I'm sure that we will come forth with some kind of an action plan by which the industry and the institutions can move forward. Excellent presentations so far, and I'm really looking forward to the rest of the evening. Thank you very much.
Thank you, Mr. Lakshminaran. So we continue with our feedback from industry. We have Ms. Mohini Kelkar of Grind Master Machines to talk on industry's expectations from mechanical engineers. Yeah.
Good morning, everybody. I hope you can see and hear me. Thanks for the opportunity to speak on this forum. The topic is close to my heart. As Mr. Lakshminarayan explained, there is indeed a gap, and every industry has to spend time to train the manpower that comes out of the institutions. We have been talking about the interactions of industry institution for a long time, and no concrete result is coming up. I would quickly narrate the gaps, and I also have some thoughts how to bridge it, and I will explain that. So the first part is on the gaps, which is in terms of the course contents, as rightly pointed out by Mr. Lakshminarayanan. The gap is in the manufacturing process knowledge or manufacturing engineering, even industrial engineering. So these topics need to be added. Apart from, I mean, it is up to the institutes how to tailor the programs, but certainly the manufacturing processes have evolved, and they are constantly evolving in terms of the CNC systems, in terms of high speeds, the processes and the machines which were taught in the Hajra Chaudhary and Chapman book for mechanical engineering are no more valid. They are the very fundamentals explained there, but lot has happened after that. And also, so these things need to be brought in the course. Such machines, CNC machines, should be available in the workshops of the engineering institutions which are there. I studied in VJTI in Bombay, and when I visited that institute after just 3 years ago, I saw that the very same machines on which I did a job of turning are there, the same foundry, and so this upgradation is extremely important. Then I wish to also say that the students coming out of all the engineering colleges, they come with the white collar. They are not willing to work with the hands, and that is the reason why workshop practice has to be continued, maybe strengthened. There has to be marking system for what comes out of the workshops produced by the students. And then I would like to mention here, of course, I agree with the digitalization and everything, but my thought is I can explain in 4Ds. And the first D is data analytics, the second is digital, and these two Ds taking over the design, the basic engineering design, is dangerous. That is what I would say, the 4Ds. So basic design and the concepts, the processes is extremely important to get the defectless world-class parts which the industry wants to produce today. The industry is getting global, and we have to make the parts to the global standard. We want to make the machines to the global standard. My company Grindmaster makes machines for micro finishing, nano finishing, and deburring, and we sell all over the world, including Japan and Germany. The biggest gap I see is actually in this execution of design and manufacturing abilities. We have extensive SOPs and checklists and training programs to really bring ourselves to the global standard. None of the institutes are talking about global. This has to be done because their customers, who is the industry, are looking at the global markets. In fact, they are very much into it. You take TVS Motor or Bosch or Tata Motors, everybody is into the exports, and so it is very, very important that this is done. Now, briefly, a few ways forward. I just heard that every institute does not have the physical workshops where the students can work. My suggestion will be there are various clusters and centers of excellence which are indeed equipped with all high world class equipments. Why can't be those facilities we can make use of? They can be scheduled with some institutes going in this slot and the machines available, making available to the students. Or if that is not possible, then set up the common facility which can be utilized by the institutes who cannot afford those kind of machines and the facilities. Another thing very important is the industrial projects. The industrial projects need not be R&D. I think it is a misconception, particularly in all IITs, that they have to do only the R&D, innovation work. Whereas the actual IITians who come out of IIT, very few are involved in the research work. They are all getting into the industry or getting into some commercial organizations. So important thing will be to connect with the industry well in advance. Speaker before me also spoke about the application of what is learned. So this is best done in the industry, and more industrial projects. They may not be a high R&D projects. They could be simple projects, but those can be executed. And for such execution, I would suggest that a group of students with a professor guiding them. So it is very essential to make the teaching faculty go and be in the industry. In industrial language, we call it Gemba. Gemba is be where the things are happening. You cannot do all these things sitting in your office or institute. You have to be on the shop floor. Be on the shop floor. Be it, if it is a civil engineering, be on the road construction, be on the bridge construction. When it is mechanical, be on the shop floor and see what is happening. And unless the professors and teaching faculty is doing this, it will never percolate to the students. It is very essential that the teaching faculty is somehow engaged, maybe through projects, maybe even working for 6 months in the industry, doing something. We had experimented this and it was good. Industry will welcome such professors also. And the most important is they will get a real hang of the things. They will know actually how the industry works, what is demanded out of them. Then my last and the important suggestion is on the sandwich course. VZTI that time when I passed out in 1981 ran production engineering course as a sandwich course. So I did my training after second year engineering, vacation training, then third year engineering, and in the last year I did 6 months complete in L&D, and I did some small projects. Maybe it may not be a high R&D project, but that really gives you an exposure in the industry, what is expected in the industry, how to work in the industry. Even it teaches you teaches a student how to work for continuously for 8 to 9 hours or be present, because the students today like to hang out more than doing a hardcore work. So these sandwich courses suddenly disappeared. I don't know why. But my frank opinion is they should be there even in the BCom course or every course. Sending the students out where the physical action is happening is important. So the crux of the thing is sending the teaching faculty and the students at Gemba, where the action is happening. That is the crux of the thing. Thank you very much for the patient hearing. Thanks a lot for giving me this opportunity.
Thank you, Ms. Kelkar, for the important insights from an industry point of view. So we now switch to Dr. Neeraj Saxena of AICTE. Talk would be on Maker Labs of do-it-yourself hands-on fabrication skills. Dr. Saxena, please. Yeah.
Good morning, and my greetings to all the experts who are championing the cause of changing the way we teach mechanical engineering to our students. At AICTE, we have initiated a scheme. It's called Idea Lab scheme, and the motivation came from the none other than our Prime Minister, who, in the wake of release of national education policy, he had said that our experiments should be the guiding principle of new age learning. Engage, explore, experience, express, excel. And he says students should engage in activities, events, and projects according to their interests. So as a response, we have created this scheme wherein we are trying to put together all the facilities under one roof that will allow students to translate an idea into a prototype. And it need not be a new idea, any existing idea, but the focus is on hands-on training, hands-on doing things with their own hands. So connecting theory with practical. So over the years, we have seen that shift has happened more towards theory, and practicals are almost sidelined. So we want to bring back that joy of doing things with hand, creating things in the laboratories. So towards this, we have initiated, and this Idea Lab is to make engineering education more engaging. We also want to push this multidisciplinary activities through this Idea Lab because it is positioned as a institutional activity and not placed in any of the departments. So we would like to see chemical engineering or even biotechnology or other departments also connecting with this Idea Lab and coming out with projects, conducting events. So that's the whole idea. So these are the requirements that we have set up. I think we can move to the next slide. So the entire focus of Idea Lab will be on the events and activities, which for which we are giving funds also, so that the whatever facility is being created is actually put to use, and the Idea Labs have to remain open for the adjoining institutions as well as the schools. Next is that these are going to be managed by students and will remain 24/7 open. So they can walk in anytime and then start working on them. So since we are going to have, we plan to have Idea Labs in all institutions, all engineering and polytechnic institutions. So it is important for us to be able to monitor. So we have already placed a device, a system through which we will be capturing information based on the activities they carry out, and they'll be given a scorecard, and that will be displayed on our Idea Lab network website so that they can see where they stand vis-a-vis the other Idea Labs. Now, in each Idea Lab, we are going to have the head of institution as the chief mentor, two faculties to be the coordinators, few student ambassadors, and few gurus who will actually be the trainers. So this is what the manpower or staffing would be like in an Idea Lab. So the whole purpose is to facilitate practical learning. And these are the people constituting the National Steering Committee. We have already identified 49 institutions, and we are shortly going to release another call for proposal to add 50 more of them. But eventually the plan is to have as many as possible, not just with AICTE support, but with the support of other state governments, industries, alumni, and all other stakeholders, those who actually want to get involved in this, what the committee says should be a movement of Idea Labs. I think I'll stop here.
Thank you, Dr. Saxena. We now move on to our next speaker, Professor K.V. Gangadharan of NIT Surathkal. Topic would be on remote and virtual mechanical lab experiments.
Okay.
Professor Gangadharan.
Yeah, thank you. My question is, can we do engineering rather than read engineering? Very simple. How can we do engineering rather than read engineering in this both difficult time as well as resource crunch activities? Can we create experiential learning modules getting embedded in the syllabus topic itself? Normally, syllabus topic is given as one sentence on what topic to be covered. But there itself as an hyperlink, let us provide experiential learning module already available online in the form of simulation, coding opportunity, actual and remote experiments. And the same remote and virtual experiments which is available online can be used as a flipped mode when we are looking at a concept, explain the concept in the class, and let the learner go and experience that in their pace, place, and period. I'm sorry, it is PACE pace. Their place, pace, and period, and make sure they come back to the class and explore more. So this is the virtual lab which can be used as concept clarity for concept clarity. Then in the present day, even the idea labs, when they mentioned, they said 49 and another 50 will be added. Remember, we have 1,800 plus institutions. Now, if we want to provide the existing facility itself for more hands-on, we can use virtual lab in the flipped mode, wherein all the theoretical concepts are covered, plus the actual experimental videos are available, which explains the procedure, gives a simulation of the same experiment, and a base data which can be downloaded. The students can do the calculation. So before they come to the actual practical class, they are well versed with the equipment, methodology, and procedure that can be used. So we now, instead of 8 students doing one experiment, we may be able to provide 2 students an experiment. The other students will watch how they are doing. They will have more opportunity to explore the experiment. So this way, with virtual lab, embedding in the syllabus, we should be able to use it in the flip mode in actual lab itself. And the virtual lab also provides an ability to fail, and learn from it. And let us reward the learning from the failure rather than punishing the failure. Because in the virtual mode, in the simulation mode, it is quite easy to provide opportunity for giving any kind of input and get the response. So that gives the opportunity to fail and learn from the failure, and let us reward the learning. And it can also be used as a DIY project idea, also in the syllabus. And in mechanical engineering, when we look at a product, we have in mechanical engineering graduate as a product. The input, the students, and the machine, the instructor, the quality is not predictable. Now then we use jigs and fixtures, which is made in controlled environment. So let us use whatever Ministry of Education has provided, like virtual lab, NPTEL, and SWAYAM courses as a soft toolkit for experiential learning, so that the new faculty as well as the learner will be able to make use of these jigs and fixtures to make production much more standard. When it is coming to mass production, standardization become much needed. So let us do engineering rather than read engineering by making experiential learning through the virtual mode getting embedded in the model curriculum, which will make sure that the resource crunch can overcome to some extent. Thank you very much.
Thank you, Professor Gangadharan. We would now invite Professor Sangeeta Kohli of IIT Delhi to speak on mechanical engineering for the society. Yeah, Sangeeta, please.
Thank you, Professor Datta, and thank you all for this great opportunity, particularly to connect back to my alma mater. So it really feels nice, and my special greetings to all my gurus sitting here. So I'm supposed to speak on mechanical engineering for the society, and many people have talked about the need for societal connect before me. So I would like to start with something that Professor B. Ravi said right in the beginning. He talked about the aspirations of most of our graduates, that is to learn, earn, and burn, and which is actually pushing them to a certain kind of jobs and certain kind of things that they are experiences that they are looking for. Now, what I would like to share with all of you, and Professor Madhusudan Rao would agree with me, that over the past 20 years, particularly many of us have seen that there are increasing number of students who are not falling in that mode of wanting to just learn, earn, and burn. In fact, they are looking for something which is much more meaningful and deeply satisfying, even if they don't earn, as much as what others aspire to earn from that. And that has actually created a cadre of students, which Professor Madhusudan Rao actually mentioned in his presentation, who are beginning to explore the avenues which are very different. So in that regard, I would like to say that something that he said, that 10 to 15% of the curricula must be addressed towards the social learning, is something that I fully agree with. And I'd just like to give some pointers towards how it can be done. So we have all spoken about connecting the students with the major applications of mechanical engineering so that their interest comes alive. But it so happens that in today's context, most of the time, the mainstream applications that we talk about are automation, health devices and systems, defense, space technologies, micro, nano, and so on and so forth. But there is a huge scope for for mechanical engineering to contribute to rural sector, which basically is to empower the artisans and craftsmen who are keeping our cultural heritage alive, and which is something that the government is trying to protect. And here, in fact, in our own experience, the problems that one encounters over there are so challenging that I am reminded of something that my own PhD supervisor from IIC, Professor H.S. Mukunda, once told me when I was working on analysis of cook stoves for my PhD, that actually designing a cook stove is much more difficult than designing a rocket, whereas he himself is a propulsion and combustion expert. So this is something that we have also experienced, that the moment you go into the interiors of the country where people are using primitive technologies as artisans in micro industries, in fact, some people have also talked about MSMEs. In MSME, 99% of the enterprises are actually micro scale enterprises who have no scope to actually either import or adopt any of the technological developments. So if mechanical engineer, and most of them we will realize have mechanical engineering applications, whether it is carpet industry, sheep shearing, cook stoves, furnaces, muri making, all kinds of, I can just spend 5 minutes in listing those kinds of examples. So the important point that I want to highlight is that mechanical engineers have to be exposed to their role in retaining the employability of the people, not just creating new jobs, but whatever self-employed people exist in our rural sector, they must be empowered, and empowered in a manner that they work in a sustainable manner. They contribute to the sustainability of the environment as well as the society. And ultimately, it's very important that we try to improve their productivity by improving their tools and the devices that they use, rather than essentially replacing their skilled hands through machines, which has been a very general trend in the past several years. So I think this is how I would like to stop. That in just one more thing, that many students from MIT and Stanford and very top class Western universities are actually coming here and trying to help those kinds of sectors, you know. And whereas we ourselves in India are mechanical engineers who can actually do a great job in helping these people, are really not paying attention to that. There are several grassroots level organizations which have technology base, which can actually be coupled with the industrial internships, and that can really help our students get an exposure where they can contribute and hence have a more meaningful professional life. Thank you.
Yeah, thank you, Sangeeta. We now move to the last speaker in this session, and we invite Professor Ashok Shettar from KLE Technological University. So we will be very happy to hear from you on the mechanical engineers from job seekers to job creators. Yeah. Professor Shettar, please.
Thank you. You are able to see my slides?
Yes.
Yes, sir. Okay. But I don't know, I'm not able to see.
Yeah, if you can make it in a full screen mode or slideshow mode. Yeah.
Thank you very much. It is my privilege to share a few of my thoughts as head of a university campus, and also from having an experience of promoting entrepreneurs. Today, my focus will be more on mechanical engineers as entrepreneurs. In particular, what are the challenges the entrepreneurship and innovation hubs in Indian campuses are having in promoting mechanical entrepreneurs? Before I touch upon the core issue, I would like to share with you the model of our university in promoting entrepreneurship in the city as well as in the campus. We are located in a typical tier 2, tier 3 city of India, where entrepreneurship and innovation culture is scarce. And at the same time, there is lack of knowledge industries as well as research intensive institutions. So when we undertook the journey of promoting entrepreneurship in a typical tier 2 or tier 3 city, we thought of a different model. Usually in engineering institutions or in universities, when we promote entrepreneurship, always we look at educate, stimulate, and incubate. But we evolved a different model which suits our needs. Just to share with you the model of our university. This is done under a Center for Technology, Innovation and Entrepreneurship. We evolved a two-pronged approach. In the initial phases, we did not focus on the students because we wanted to create this entrepreneurial ecosystem which can support the students in later stages. So in the first stage, we tried to attract and support external senior serial entrepreneurs. In the sense, the entrepreneurs who have already the companies but are located in bigger metros, we tried to attract them to Hubli by creating certain value proposition. We're pretty successful in it. We're able to attract 4 or 5 big anchor companies into the campus. Now, their presence in the campus was used to build a kind of a E&I culture, entrepreneur and innovation culture within the campus. We used this ecosystem to drive the student community towards entrepreneurship. In time, university designed a lot of formal and informal interventions to support the student community to move towards entrepreneurship. This is a unique model of KLE Technological University, which we are practicing from last 12 years. Just to briefly touch upon the impact of this particular model or particular initiative. So far, 80 plus startups we have incubated in Hubli, Dharwad. Out of this 80 plus, 26 are student startups, and all of them are from undergraduate students. We have created, these companies have created more than 1,500 jobs, which is big for the city like Hubli. And whatever these initiatives we carried out, we are able to connect to more than 7,000 students. I'm very proud to say that very few companies have graduated very big companies from the campus. We are able to graduate 2 companies which are valued more than 200 crore at this point of time. And in recent years, several other campuses located in India, in tier 2 cities, are adopting this model to drive the entrepreneurship. And most importantly, apart from all this impact, a strong E&I culture we are able to drive in the region. Today, in fact, entrepreneurship is a very hot word in Hubli Dharwad. I mean, every youngster talks about it. That is the impact of our journey. But when we look at the companies we have incubated, there is a concern. When I look at the domains of the startups we incubated from 2010 to 2018, majority of them belong to IT and electronics. You can see that 57% of the startups are in IT, 25% is in ESDM, and few are there in biotech, and all other domain together it is 7%. Mechanical entrepreneurs venturing into the companies from mechanical is very minimal, that is less than 5%. I believe this is a very similar story we can see across other TBIs, technology business incubators in the campuses. This concern made us to think differently, and that is what I would like to share with you. So when we looked at the scenario and saw that there are very minimal mechanical enterprises coming up in our incubation, we did lot of brainstorming. We did lot of deliberations. Then probably we felt that these are the barriers that are there for promoting mechanical engineers in campuses. One, definitely, usually these ventures require large initial investment, and there is a lack of venture funding in this sector. Many of our student startups were funded at a very early stage by the ventures, but when it came to mechanical, okay, there was a problem. So unlike IT, venture funding in this sector is not mature. The third thing is the role models matter a lot. There are no Narayana Murthis or Zuckerbergs the students can see in mechanical engineering. Okay, even though there are big companies all around us, okay, they have their own legacy. But from the campus, a company graduated from the campus, okay, we are not able to, students are not able to see, there are no role models, okay. And at the same time, the ecosystem that is required for the growth of these companies, these startups, is also lacking. The fourth and most important is the student themselves are not prepared for the evolving nature of the mechanical industry. Okay. Because somewhere in education we have failed. So today, mechanical engineering product is highly multidisciplinary. Our education need to prepare them for it, for this reality. But I believe somewhere we are not able to fulfill this particular need. Then after identifying these barriers, we tried to come up with our own strategy. We established a center, which is called as Innovation and Product Development Center, with three objectives. One is build a supporting infrastructure that is required for mechanical engineers. In fact, we invested more than 5 crores in creating what we call as a learning factory with a production capacity machines, whether it is a 3D printing or CNC machines or laser cutting machines. So whatever was required for rapid prototyping of electromechanical systems and products, and also the testing facilities. The second thing was we are trying to build a multidisciplinary expert support system. Under the CIPD, we try to bring in the experts for mentoring and guiding these particular, startups in mechanical. And at the same time, another critical thing we saw that, okay, these startups cannot master all the technologies. How about building the network between the companies that are there in the campus, in the area of ESDM, in the area of VLSI? So can they work collaboratively to realize the product? That is something we are trying, and to a large extent we are successful. So in fact, these three
Dr.
I
Shekhar,
think he's
you're
muted.
audible.
The voice is gone.
I think he's muted by mistake.
Okay. Dr. Shekhar, you're muted.
Yeah, accidentally.
Yeah, Professor Shekhar.
Yeah, am I audible?
Yeah, now you're audible. Thank you.
So
please wrap up.
After these initiatives, we are able to see some good progress happening in many sectors. There are startups in defense sector, there are startups in Medicare, as well as in electrical vehicles. But there need to be lot to be achieved, I can say. But most importantly, I believe there need to be a transformation in our mechanical engineering education. Like earlier, many speakers were mentioning, okay, we have to prepare our students for a multidisciplinary world. We need to bring new verticals. We need to bring more minor kind of experiences. That is something which we are working on. I can't say at this point of time we have a solution, but we are progressing towards this. I believe this is what is required from every institution. And lastly, mechanical engineering entrepreneurs must realize that it is the interdisciplinary space where the opportunity lies. Okay? Automation, smart system, AI/ML driven solutions, and at the same time, new technologies that are evolving in electrical vehicles, fusion of power and electronics with mechanical systems. Many novel concepts are getting attentions from financiers. Okay, these are the things they should be looking at. But ultimately, what I feel is preparing them, apart from all the support structure we put inside our campuses, preparing them for the new opportunities is the challenge for the universities and colleges. Thank you. Thank you so much for this opportunity to share a few of my thoughts.
Thank you, Professor Shetter. And I would also like to thank all the speakers for the wonderful spectrum of distilled thoughts, towards modernizing the mechanical engineering curriculum. Let me summarize briefly all the thoughts that have come in, starting with Professor Ghosh, his talk on science as a foundation, in which his main message was flexibility with the fundamentals. And he laid down a wonderful pathway to modernization of mechanical engineering curriculum, keeping the scientific foundation intact. And after that, we had Professor Samir Khandekar on the mechanical engineering teaching and learning ecosystems, in which the main message was that technology cannot be isolated from society. And this was later emphasized by Professor Sangeeta Kohli on the specifics of what it means to connect with the society, for the mechanical engineers. And then we also had a few lectures on modernization of the curriculum, starting with Professor Rudra Pratap on modernizing the ME education, and he presented from a historical perspective. And later that was elaborated by Dr. Neeraj Saxena on the do-it-yourself hands-on fabrication skills with the concept of Idea Lab network, and then by Professor Gangadharan on the remote and virtual mechanical engineering lab experiments. And we also had a couple of talks, good insights from industry. One from Mr. Lakshmi Narayan of TVS Automotive System on the expectation from the industry as far as employability skill sets are concerned. And that was re-emphasized by Ms. Mohini Kelkar on the on the same issue of what kind of skill sets or what kind of expectations are there from the industry. And finally, the other side of it, that mechanical engineers not as job seekers, but also as job creators from an entrepreneurship point of view, it was presented very nicely by Professor Shetter, because ultimately it's not just creating engineers, but they have to be employed. So the insight on the job creation, so that the entire ecosystem of education and then finally end users of our educated products comes to there's a closure on that, and then the entire system is sustainable. That is what was emphasized by him. So with that, we would like to conclude this session. We have shot over some time. So Suresh, you have to handle it now, from now on to the rest of the workshop. So over to you, Suresh and Ravi.
Yeah.
Thank you, Pradeep, and all the speakers. I think even though we overshot the schedule, but I think we can make up. We have also Pradeep for the thanks for the excellent summary of all the distilled thoughts. You distilled the distilled thoughts. And next one is our breakout sessions. We have 6 of them, and we were supposed to start at 11 o'clock. Now it's 11:48. So Professor Ravi and I discussed it, and he's going to explain how the breakout sessions will work. Ravi?
Yeah, so good afternoon again. I think I'm saying afternoon because it's almost getting to noon. So what we have is we have these 6 breakout sessions. Suresh, if you can bring out the session titles as we speak, if you can. I'll just explain how it works. So there are 6 breakout rooms. Essentially what we did was to look at in terms of types of courses in mechanical engineering. So if you look at it, that's 11 to 12 o'clock. To start with, let us not worry that it is only 15 minutes only or 10 minutes. We just took a call that we'll extend it to 12:30. Okay, so that means we get about, I think, about 40 minutes or so. What we would request all the participants is to enter one of those 6 rooms depending on your interest. Whether you would like to look at that first year science engineering introduction courses, then that is the room number 1 with Professor Ghosh and Professor PVM Rao. If you would like to look at the core mechanical engineering courses, the bulk of it, Professor Kuthi and Baji Rao's room, number 2. Number 3, third room is about these technology courses, whether it is CAD/CAM or whether it is some application technologies like refrigeration, air conditioning, those courses. Professor Pradeep Datta and Chandrasekhar would be co-chairing that. Professor Anand Suresh, room number 4, along with Professor Sujata, assuming she's still there, will look at interdisciplinary, multidisciplinary, transdisciplinary minor courses, whatever they are there, and of course what should be there. And Dr. Naga and Dr. Gangadharan could look at practical lab skills and internship and project also. And Professor Sangeeta and me would like to look at humanities and professional skill courses, including English speaking and things like that. Now the point is that what you have done to enable the whole breakout is that each session chairman has a PPT with the existing list of courses, along with the list of outcomes that is prescribed by AICTE. Because time is too short, I think we would like to just maybe focus on